Hello, Algebra 1 students, and welcome back to your Semester 2 final review. Today we're on to problem 13, and you're probably coming to this one after problem 12, and maybe you glanced at the none up here, and you're like, well, did you actually teach me anything this year? Because we know that this none means this is another topic that we didn't cover this year. I promise you did learn something this year, and there aren't too many nuns, but they come in packs because the couple things we didn't teach you are related to each other. So, write an explicit formula for the geometric sequence that has terms a sub 3 equals 1 and a sub 5 equals 0.25. Okay, let's break this down. First, they're asking about an explicit formula. An explicit formula is just a typical formula, right? A regular formula that you're used to. A geometric sequence is a fun way to say an exponential formula. A geometric sequence has the pattern that you multiply by a common ratio every time, and that's what we call exponential. It's just kind of a fancier, different way to say exponential. Last but not least, they give us terms a sub 3 equals 1 and a sub 5 equals 0.25. You've seen these subscripts before with the slope formula, right? Y sub 2, y sub 1, and they're just telling us that these are different values. They wouldn't just want to say a equals 1 and a equals 0.25, because then you're like, wait, which a is which? So they just give you those little subscripts there. It goes a little bit further, and just like the last one, we're going to go through and make a quick xy table. Okay, I'm going to start x at 0, and we're going to work our way up here. 1, 2, 3, 4, 5. There we go. I've probably made better tables, but that's okay. And what do we know? Well, I have y here, but they're using this a sub n as our output. Just think of that as y, but I'll put a sub n down here not to confuse you. And then same thing for the inputs. It looks like they use the letter n instead of x, but same idea here. We know that when n is 3, a sub n is 1, and when n is 5, a sub n is 0.25. Our goal is to write a formula that matches this table. Now, if you look at the formulas up above, they're kind of in that form of a times b to the x power, right? And I'm just going to remind you y equals a times b to the x power, or there's a couple things going on. B is our common ratio, the number we multiply by every time, and a is usually our y-intercept. Okay? Looking at this, we have a couple problems. The first problem is that I'm not sure what the common ratio is, and the second problem is we don't have the y-intercept. There's actually a third problem, but we'll come back to that in a bit. So let's see if we can find that common ratio. Now, if we look at this, we know our common ratio is going to go through and multiply by a number each time, and it has to be the same number. So if we call that number b, our common ratio, what's really going on here is we have 1 times b, and when we finish doing that, the answer is going to be 0.25. Right? If you multiply times b the first time, you get here, and then times b again equals 0.25. All right? Well, as we do that, 1 times b times b times b we know is b squared. And we also know we don't really need to write the 1 in front, so we end up with b squared equals 0.25. There's two ways to think about this. The first way is what times itself gives you 0.25, or as a fraction, 1/4. But the other way, since we actually know a little bit of algebra to solve this right now, is we could actually take the square root of both sides, because we know a square root undoes a square. And if you put 0.25 or the square root of 1/4 into your calculator, you'll find that b is 0.5 or 1/2. And I bet logically that'll make some amount of sense to you, because if you look at this, if you do half of 1, you get to 1/2. And then if you do half of a half, right, if you have half a cake and then you only eat half of that, you end up with 1/4 of the cake. Okay? So that actually already gives us the answer up here, because if you're looking at the b values, only one of them is 1/2. I'm pretty convinced it needs to be b. But we do want to finish up this problem because the one on the final might not be as straightforward. So let's try and fill in the rest of this. So we know by now our formula is going to be a times 1/2 to the x power. What about that a value? Well, let's just work backwards. If you take half of a number to move forwards, then how do we get from a half to a whole? Well, to move the other way then, and I'll just do this up here, you're multiplying by 2, right? So if we multiply by 2 each time, times 2, this will give us 2, 4, 8. Doesn't that hold? If we do half of 8, it's 4, half of 4 is 2, half of 2 is 1, and so on and so forth? Yeah. So we now can update our formula once again as 8 times 1/2 to the x power. But unfortunately, none of these up here are 8 times 1/2 to the x power. Right? We have an 8, but not a 1/2. We have an 8 in the wrong spot. We have a 1/2, but no 8. And here, especially, there's a 1/2 and no 8. So what's different about their answers versus ours? Their answers have this weird n-1 piece. And that's really indicative, that's really a good giveaway that they're using this geometric sequence idea with this n-1. Now, what we can think of here is actually a weird version of HK form. So our HK form with exponentials, and we didn't do much of HK form here, you'll do that in Algebra too. You can think of it as still our b value here, and we're going to do x minus h times k. Instead of plus k, it's a times k. And that's because we're exponential instead of our adding and subtracting sort of thing. So if we think about our HK form, HK uses a point. And so we can actually build quite a few of these. B is going to be 1/2 every time. Let's look at a couple HK values. 0, 8, x minus 0 times 8. That is one formula that would work. But if we wanted another one, 1/2 to the x minus, you could use this next one, x minus 1 with a times 4. Or let's try one more just to make sure you understand what's going on here. For our HK form, x minus, and we could do this next one, x minus 2 with a times 2. All of these formulas make the exact same graph. With sequences, typically they start with the first term, which is why they use the x minus 1 piece, and hopefully we can see this first term does match our answer. Realistically though, if you want to spend more time on this, you want more practice problems, we have plenty of them for you, but it's a super small piece of math, explicit sequences using that n-1 or that first term. So hopefully this made a little bit of sense. Again, if you want some more practice and you have plenty of time before your final, please talk to your teacher. We have plenty of practice problems like this. Thanks for tuning in and excited to keep helping you succeed on your final exam.